Section 7.2 was on multiplying and dividing rationals. So I just want to do a really quick example of if we have real numbers, if we're multiplying fractions. If I had 1/3 times 9/4, we can just multiply across. 1 times 9 is 9. 3 times 4 is 12. And then we always have to reduce them. So 3 goes into 9 3 times. 3 goes into 12 4 times. So that reduces to 3/4. I also could have done it from the beginning before I even multiply it out. 3 goes into 3 1 time. 3 goes into 9 3 times. And then I'm left with 1 times 3 on top, which is 3. 1 times 4 on the bottom, which is 4. So when we're multiplying these fractions or rational expressions, we multiply the numerators together and the denominators together. And you always, always, always have to simplify. And we really want to simplify first, because we're not going to be just using real numbers. We're going to be working with variables. So for example, if I have 3x squared over 4y times 12y squared over 4x, I can multiply all that stuff together. It just kind of gets big quickly. So it's a little bit easier if I simplify it first. And you can, as long as one thing's in the numerator and the other in the denominator, you can simplify, which is what we just did in 7.1. So I can take the fact that 4 goes into 12 3 times here and 4 goes into 4 once there and simplify that. I can also deal with these x's. That x would take out one of these x's, so that exponent is now going to be a 1. And this y would take out one of these y's, so that exponent's going to be a 1. So I'm left with 3 times 3, which is 9, and then I have an x there and a y there, so I get 9xy on top. And on the bottom, everything else simplified to a 1 except for that 4 out front. So it simplifies to 9xy over 4. If I don't have it just one single term in each numerator and denominator, sometimes I'm going to have to factor it. Sometimes it'll already be in factored form. So I have a plus 2 over a minus 2 times 1 over a plus 2. Well, there's nothing to factor, right? Each of these are just kind of linear in each numerator and denominator. And these match exactly. So that a plus 2 on top and then this one in the denominator are going to cancel. And I'm left with 1 over a minus 2. All right, my next one, I have 4 minus x squared over 2 plus x times x minus 1 over x squared minus 3x plus 2. So this denominator, nothing to factor. That numerator, nothing to factor. But the other two, I can. So 4 minus x squared is a difference of two perfect squares. So I get 2 minus x times 2 plus x. And then x squared minus 3x plus 2 factors to x minus 1 times x minus 2. All right, so what can we cancel out? Well, 2 plus x and 2 plus x, those are the same. That simplifies to a 1. X minus 1 and x minus 1, that simplifies to a 1. And then we have 2 minus x and x minus 2. So remember, that's that case that when they just are, if you multiply negative 1 by 1, you get the other one, it simplifies to a negative 1. So these two just simplify to a negative 1, and this whole thing just goes to negative 1. So that's the multiplying. And again, go back over your other notes, because I have all your class notes should be filled in for this as well. And the second part to this is division. So when we're dividing fractions, we have to flip and multiply. So if I had 2/7 divided by 4/3, I need to do a rewrite and make it 2/7 times 3/4. So that division becomes a multiplication, and what's after the division sign gets flipped, right? So I flip that, and I change the sign to division. Oh, sorry, this isn't coming out too well on the video, but flip the top, change the sign. All right, now I can actually reduce it before I multiply it. So 2 goes into 2 once, 2 goes into 4 twice. So I'm left with 1 times 3 on top and 7 times 2 on the bottom. So after you turn it into a multiplication, it's exactly the same as what we were doing. Well, I have an example, of course. X squared minus 5x plus 4 over x squared minus 1. And I want to divide that by x squared minus x minus 12 over x plus 1 squared. So remember that x squared means whatever's in front, you're multiplying it by itself. So this is x plus 1 times x plus 1. So when I go to rewrite it, I'm actually going to expand it out just in case one of those factors cancel. So x squared minus 5x plus 4 over x squared minus 1 times x plus 1 times x plus 1. I just expanded that squared over x squared minus x minus 12. So now that it's a multiplication, I'm going to factor every single numerator and denominator as much as possible so I can see what cancels. So starting with the x squared minus 5x plus 4, that factors to x minus 1 times x minus 4. Underneath it, I have the difference of two perfect squares, so x plus 1, x minus 1. I already expanded that x plus 1 squared out. And then lastly, I get for x squared minus x minus 12 is x minus 4 times x plus 3. All right, every single thing is factored out, and now I can start canceling. So I have an x minus 4 and an x minus 4. That simplifies to a 1. I have x plus 1, x plus 1. I have x minus 1 and x minus 1. So only thing I have left is x plus 1 on top and an x plus 3 on the bottom. All right, let me see. I have a bunch of random problems in front of me, so I'm just trying to pick one that I think would be good. All right, I have m squared plus 9m plus 18 over m squared plus 6m plus 9. And I'm going to divide that by m squared minus 9m plus 20 over m minus 4. Again, I have a division, so I need to flip it. So again, what's after the division sign is always what gets flipped. And some people factor it as they go along. To me, I think people make more mistakes when they do that. So I'm just rewriting it and then factoring each part. So m squared plus 9m plus 18 is m plus 3 times m plus 6. Underneath it, the m squared plus 6m plus 9 is m plus 3 times m plus 3. M minus 4, there's nothing to factor. And then lastly, that m squared minus 9m plus 20 is m minus 4 times m minus 5. Okay, that's everything. So m minus 4s, m plus 3, and that is it. So I'm left with an m plus 6 on top and an m plus 3 times m minus 5 on the bottom.